August 12th, 2022. Somewhere in western Ukraine, inside a hardened aircraft shelter. The fluorescent lights hum overhead. Colonel Andriy Kovalenko stands in front of a MiG-29 Fulcrum, arms crossed, staring at the problem that shouldn't exist. There's nothing more perplexing, confusing, and chaotic than being handed a weapon system that simply cannot work with what you have. It's one thing having time to plan, to consider your options and courses of action, but it's quite another when you're told you have 3 weeks to do the impossible. This is a time for a cool, decisive head. Otherwise, the consequences can be dire. Beside him, 3 engineers, Dmytro, Alexander, and Yuri, are crouched near the fighter's left wing pylon, tools scattered across the oil-stained concrete. On a metal cart 10 feet away sits an AGM-88 HARM anti-radiation missile, sleek, American. Its guidance fins gleaming under the harsh light. It's a weapon designed to hunt and kill enemy radar systems. It's also completely incompatible with the Soviet-era jet in front of them. Tell me again why this is impossible, Kovalenko says, his voice flat. Dmytro looks up, wiping sweat from his forehead. Because the MiG-29 uses a PRNK-29 navigation system, Soviet architecture. The HARM uses the MILSTD-1760 databus and NATO architecture. They don't speak the same language. The electrical interfaces are different. The mounting lugs are different. The fire control logic is different. We don't have schematics for either system. And even if we did, we have 3 weeks, Kovalenko interrupts. The shelter falls silent, except for the distant rumble of a generator outside. 3 weeks. That's the timeline the General Staff has given them. 3 weeks to turn a Cold War relic into a platform capable of firing one of the most advanced anti-radiation missiles in the world. 3 weeks to do what Lockheed Martin and Mikoyan engineers would say requires years of integration testing, millions of dollars, and access to classified technical data. Outside, the war is grinding forward. Russian S-300 and S-400 air defense systems form an interlocking web across the eastern front. Their search radars sweeping the sky, forcing Ukrainian jets to fly low, limiting their effectiveness, bleeding away their advantage. Every sortie is a gamble. Every pilot who takes off knows the odds. The Ukrainian Air Force needs a way to punch through that radar curtain. They need the HARM, and they need it now. Alexander stands, brushing dust off his knees. He's the oldest of the 3 engineers, a veteran of the Soviet Air Force who's worked on MiG-29 since the 1980s. The Americans sent us 12 missiles, he says quietly. No manuals, no integration kits, just the missiles and a note saying good luck. Kovalenko nods. He's read the note. It isn't callousness, it's reality. The US can't send technical documentation without risking classified information falling into Russian hands. And even if they could, the HARM has never been designed to interface with Soviet avionics. This isn't a matter of translation. This is a matter of making 2 incompatible systems talk to each other without a common language. Yuri, the youngest of the group, is already sketching on a notepad. We bypassed the fire control computer entirely, he says, thinking aloud. We hardwire the missile seeker head directly to a handheld GPS unit and a simple trigger switch in the cockpit. The pilot selects the target coordinates manually. The HARM's internal seeker does the rest. Dmytro shakes his head. That's insane. You're talking about turning a precision-guided munition into a point-and-shoot weapon. No data link. No pre-launch diagnostics. The pilot won't even know if the missile is locked on. Then we add a status light, Yuri shoots back. Green for ready, red for fault. Simple. Simple, Dmytro repeats, his voice dripping with sarcasm. You want to strap $1 million missile to a jet using improvised wiring and a status light from a car dashboard. Do you have a better idea? Silence. Kovalenko steps forward, his boots echoing on the concrete. He places a hand on the MiG-29's fuselage, feeling the cold metal beneath his palm. This jet was built in 1989, rolled off the assembly line in a factory that no longer exists, in a country that no longer exists. It's flown patrols over the Black Sea, intercepted Turkish reconnaissance planes, sat in storage for a decade after the Soviet collapse. Now, it's being asked to do something its designers never imagined. We start with the pylon mounts, Kovalenko says. Machine new adapter brackets. Then we figure out the electrical interface, one step at a time. The engineers exchange glances. They all know what this means. No sleep, no safety margins, no room for error. If they fail, Ukrainian pilots will continue flying into a meat grinder. If they succeed, they might just change the course of the war. Dmytro picks up a wrench. One step at a time, he echoes. And so it begins. The first problem is physical. The AGM-88's mounting lugs are spaced for NATO standard pylons 1, 4-inch intervals designed for F-16S and FA-18S. The MiG-29's wing hardpoints use Soviet BD-36021D pylons with completely different geometry. It's amazing to think how different engineering standards were during the Cold War compared to today. There's no universal compatibility, no standardization. Most Soviet aircraft didn't even share parts with NATO jets until decades later. So an adapter bracket, even a simple one, has to be fabricated from scratch. Alexander spends 2 days in the machine shop, fabricating custom adapter plates from aircraft-grade aluminum, drilling and tapping holes by hand, checking tolerances with calipers under a magnifying lamp. By August 15th, they have a bracket that fits barely. The electrical problem is worse. Yuri's idea bypassing the fire control system entirely is the only option that doesn't require rewriting the MiG's avionics software, which they can't do without source code they don't have. So they improvise. They pull wiring harnesses from a scrapped Su-25, splice in connectors salvaged from agricultural equipment, and run new cables through the MiG's wing conduits using a fish tape and prayer. The HARM seeker head needs power and a launch signal. They give it both, routing two 8-volt DC directly from the jet's electrical bus through a relay controlled by a toggle switch mounted on the throttle quadrant. This is either brilliant or suicidal, Dmytro mutters on day 9, soldering connections inside the cramped avionics bay while Yuri holds a flashlight. Both, Yuri replies. They test the electrical continuity on August 18th. Green light. The missile is receiving power, but power isn't enough. The HARM needs target coordinates, latitude, longitude, and frequency range of the enemy radar. Without the MiG's fire control computer feeding that data, they need another solution. Yuri mounts a civilian Garmin GPS unit to the cockpit glare shield with Velcro and duct tape. The pilot will input coordinates manually, then flip the arming switch. The HARM's internal seeker will do the rest, homing in on radar emissions within a 10-kilometer radius. It's crude, it's dangerous, it's also the only way. On August 22nd, they roll the modified MiG-29 onto the tarmac for the first ground test. Colonel Kovalenko stands beside the jet, watching as Captain Maxim Ivanov climbs into the cockpit. Ivanov is a veteran pilot, 15 years in the Air Force, over 800 hours in the Fulcrum. He's volunteered for this. He knows what it means. "Power up," Kovalenko says into his radio. The MiG's engines spool to life. Twin Klimov RD-33 turbofans roaring in the morning air. Inside the cockpit, Ivanov flips the master arm switch, then toggles the HARM's power relay. The status light, a simple LED, Yuri, has wired into the panel glows green. "Seeker active," Ivanov reports, his voice crackling over the radio. "I have tone," Kovalenko exhales. It works. On the ground, at least. The real test comes 2 days later. August 24th, Ukrainian Independence Day. The irony isn't lost on anyone. They fly the MiG-29 to a forward airbase near the contact line, loaded with a single live AGM-88 HARM. The target: a Russian 96L6E acquisition radar, part of an S-400 battery operating 40 kilometers inside occupied territory. Intelligence has pinpointed its location. The radar is active, sweeping the sky, guiding surface-to-air missiles that have already downed 3 Ukrainian aircraft that month. Ivanov takes off at dawn, climbing to 8,000 meters before turning east. The plan is simple. Get within range, lock the HARM onto the radar's emissions, fire, and get out before the S-400 can respond. No data link means no confirmation of lock until the missile is already in the air. No pre-launch diagnostics means no way to know if the seeker is functioning until it's too late to abort. At 60 kilometers out, Ivanov arms the missile. The green light flickers, then holds steady. He enters the target coordinates into the Garmin, cross-checks his heading, and pushes the throttles forward. 50 kilometers, 40. The HARM seeker begins tracking, its internal processor analyzing the electromagnetic spectrum, hunting for the telltale signature of the 96L6E's S-band emissions. 30 kilometers. Ivanov's radar warning receiver screams. The S-400 has detected him. He has seconds. He squeezes the trigger. The HARM drops from the pylon, its rocket motor igniting a heartbeat later. It accelerates to Mach 2, arcing downward, following the invisible thread of radar energy back to its source. Ivanov banks hard left, diving, jamming the throttles to full afterburner. Behind him, an S-400 missile launches, climbing fast, but he's already below the radar horizon, skimming the treetops, racing west. 60 seconds later, the HARM strikes. The 96L6E radar explodes in a fireball, its antenna array shredded, its operators dead or fleeing. The S-400 battery goes dark, blind, unable to guide its missiles. Ukrainian strike aircraft follow minutes later, hitting targets that have been untouchable for months. When Ivanov lands, Kovalenko is waiting on the tarmac. The pilot climbs out of the cockpit, pulls off his helmet, and grins. "It worked," he says simply. Kovalenko nods. "It worked." In 3 weeks, with no manuals, no technical support, and no margin for error, Ukrainian engineers have done the impossible. They've turned a Soviet-era fighter into a platform for NATO's most advanced anti-radiation missile. They've proven that desperation and ingenuity can overcome decades of incompatible design philosophy. And they've given their Air Force a weapon that will help turn the tide. The MiG-29 will fly dozens more HARM missions in the months that follow, suppressing Russian air defenses, opening corridors for strikes deep into occupied territory. The improvised system isn't perfect. Pilots still fly without full diagnostics, still rely on handheld GPS units and jury-rigged wiring, but it works. And in war, that's enough. From my own experience, there's always that moment when you realize you've achieved something that shouldn't have been possible. I'm certain that Colonel Kovalenko and his team, standing on that tarmac in August 2022, had exactly that feeling. Years from now, military historians will study this moment. They'll write papers about hybrid weapons integration, about asymmetric warfare, about the ingenuity born from necessity. But in that shelter in August 2022, it wasn't about history. It was about survival. It was about 3 engineers, a colonel, and a pilot who refused to accept the word impossible. And it was about a MiG-29 that learned to speak a new language.